Okay, this is a video tutorial on the Big Ideas Geometry section 4.3 titled Rotations. And your main objective is to be able to perform rotations, mainly in a coordinate plane. So we're going to be graphing objects, looking at a couple rules on depending the direction and distance of that rotation, and then graphing our new image. So a rotation is a transformation where a figure is turned around a fixed point called the center of rotation. And the ways you can determine how far you're being rotated is to draw rays from that center of rotation to a point and its new image that form the angle of rotation. So in this diagram, we have this RQ triangle with a line figure, and it is being rotated around this point BP, which is the center of rotation, 40 degrees counterclockwise. So your new image is this red RQ prime, and it is being rotated 40 degrees counterclockwise around your center of rotation point P. So the direction is always going to be clockwise or counterclockwise. So think about the directions that hands on a clock travel. And then your angle is just how far it's going to go. So 90 would be a quarter of the way, 180 would be a half, 270 would be 3/4, and 360 would be all the way around. So some of those numbers in between will help you. So now the specific rules that we're going to talk about when you have specific points. So we're starting with point AB, and if that is being rotated counterclockwise around the origin, which is the point 0, 0, you can just follow these rules to get your new coordinate points without even having to draw them. So if you're rotating a point 90 degrees counterclockwise around the origin, you take your AB, you switch the order of them, and then you make your new x-coordinate opposite sign. So if it was positive, it becomes negative, and if it's negative, it now becomes positive. For 180 degrees, you keep your numbers the same, you just change them to be opposites. So if your AB was 2, 3, and you're rotating 180 degrees, it would just now become -2, -3. 270 degrees, you change the order, so you swap your A and B, but this time your Y coordinate is now going to be opposite signs. So it goes from negative to positive or positive from negative. So keep these rules handy. It's always your map or your guide for when you are rotating around the origin, and it is always counterclockwise. So let's take a look at an example with a quadrilateral. RSTU with the given vertices 3, 1, 5, 1, 5, -3, 2, -1, and is being rotated 270 degrees around the origin. So we're actually able to figure out our new coordinates without ever having to graph them first. We can just find the new coordinates, graph the first one, and then graph the second one to check. So since it's 270, we're going to follow the rule of switching the order of the numbers and changing the sign of our new y coordinate. So let's look at these one by one. First, we have our r coordinate, which is +3, +1. We're going to change the order of our numbers. 1 goes first, and then 3 becomes a negative because our y coordinate always changes sign. Let's look at our s coordinate. We have a 5, 1. Change the order and make your y coordinate change sign. So from 5, 1, you change the order, and then your 5 now becomes negative. 5, -3. You change the order, and then you make your second coordinate change sign. So the -3 stays the same because we're not changing our x coordinate. The 5 becomes negative because we change our second coordinate. 2, -1, change the order, and then make your y coordinate opposite sign. So we have -1, -2 now. So those are our new coordinates after it's being rotated. So when we graph those, first we can graph our pre-image points, so the original RSTU, and then you can connect the dots, the lines between them. So this is our original starting quadrilateral. Then we're going to plot our new image points after it is being rotated 270 degrees counterclockwise around the origin. So this is our new R image. It is at the point 1, -3. This is our new S image at 1, -5. T is at -3, -5. And U is at -1, -2. Notice how when you connect the dots, this is the exact same shape and the exact same size. These two things are congruent. You're just moving them in a way that is rotated 270 degrees around the origin.